So, as was my introduction, we'll be talking about Ecto without schemas, and as you can see, it's like it can be a challenging topic. But before we get into the meat of the talk, just a short thing about myself. I'm Benjamin Milde. I'm a developer and co-founder of a small company in Munich called Made It. And I'm rather active in the Elixir community, and my name is there, Lost Cobra Kai, which you might have seen. So, Ecto without schemas. Why would you want to do that? Like, Ecto schemas are a core part of the library. They work perfectly fine, but there are some cases where you just cannot use them. So for me, the reason for getting into that topic was really a little bit of fun and profit. Like, there's interesting APIs in Ecto, which you only discover if you actually put yourself under some constraints. But for me personally, there's also another reason, and that's a system called ProcessWire, which I used before I learned about Elixir. And ProcessWire is a small niche CMS. There's like, I don't think there's anything like, there's no requirement to know ProcessWire specifically. But I really like the system and how it approached managing content, and therefore, for the last 3 years, I've been on and off trying to replicate something like ProcessWire in Phoenix and with Ecto. And in this talk, we'll be exploring part of that like journey. ProcessWire as a CMS essentially allows you to define user content at runtime. So essentially, the system itself doesn't know anything about the content which will be stored in the system. And one point about that, it even changes the database at runtime. So there's just a few challenges to be had with Ecto if you're not aware like which tables there even might be in there. So without schemas, what do we need to care for? There's a few things which are constraining our use of Ecto when we are using it without schemas. There's a much larger need for composition. Usually you can build like, you have a report to build, so you just build the query for it, and that's it. You know where the data is, so you can just write a query for it. If you don't know where the data is, you need to have functions which can work with the certain data you have at runtime and convert that into a query. Then the other issue is with anything which is only created at runtime, you need to be aware that you're not creating additional atoms based on user input, which is always a concern. And also, like, this topic goes beyond the usual documentations and how-tos about Ecto, especially because it's not a common use case, but also it's a little more tricky. It requires a little more setup than what is usually good for documentation or how-tos. So the feature of ProcessWire we'll be looking at today is selectors, which I'll get into what it is later. But before we get to that, I need to show you a little bit about how ProcessWire works to have an understanding for what we'll do later. The high-level data model in ProcessWire is that there are essentially pages where you fill in the content in fields. Each page has a template, and a template essentially is a collection of many fields which you need for certain content. To go with the usual blog example, essentially, a template might be a blog post which has a title field, a body field, some image field, and the pages are then the actual blog posts you have in your system. In the database, this looks a little bit like on the side. There are some non-controversial tables, pages table, which lists pages, templates table, fields table. Those are not that interesting. The interesting ones are then the lower ones. So for each field in the system, there's a custom table created by the CMS, which is just field underscore and then the name of the field. So that's what I was hinting at with the database is even changed at runtime. So selectors are then essentially a way to query for those pages. It's a text-based DSL essentially for selecting pages out of the system. Just a quick overview of a few examples, like you can select all products, you can have you can query essentially multiple fields as an option to each other. So they're essentially either title or body needs to have the sushi value. Same can be done with the values of fields. And those selectors or those conditions can then essentially be composed to have more complex essentially conditions. So the last one is essentially get me all products that are still in stock and on promotion. And to get back to Ecto, how would one actually implement something like selectors in Ecto? The interesting part is that Ecto is actually quite open to it. There's an Ecto queryable protocol which allows you to define like custom data types to query for data. And the protocol is actually not that complicated. It's essentially a turn the data I have into an Ecto query eventually. And I think all of you have already worked with that because Ecto actually ships a few interesting implementations for that. As you can see here, the first one is probably one everyone has used here. You can pass a schema module into repo all, and Ecto figures out which table to query and which columns to query. And that's done using the Ecto queryable protocol. There's some they are just for completeness, so Ecto query for sure can be turned into an Ecto query. There's also a subquery struct in Ecto, which also implements that protocol just for Ecto's subquery handling. The more interesting ones are actually then at the bottom. So there's an implementation of the queryable protocol for binary, which allows you to just pass a plain table name into APIs on Ecto. You can see here there's two examples of that because for Ecto aggregate you can just pass in the table name and it just works. If you're selecting data, you also need to tell Ecto which columns you actually want to know. So in this case you still kind of need to create a query. And on the last line there's actually an interesting one. You can, if you have data in multiple tables which has a similar shape, you can actually reuse a schema you have and just assign it a different table name than is defined on the schema itself. And for next steps, what do we need for a custom implementation for that protocol? So if we want to have something like those selectors which we have seen in Ecto, we need some parser. We have seen some parsing yesterday in the DSL talk. We need to have a struct which we define a protocol for because as mentioned, Ecto already provides a implementation for binaries, so we sadly can't use that. And then eventually we also need to turn the data structure which we get out of the parser into an actual query for the database because eventually it needs to be SQL at some point. So for the first step, just a quick overview of the format of the selector. It's essentially one or many fields which we query for, then one of a few handful of operators, and then one or many values which we check for. And just a minor detail like those values might also be quoted. And then comma separated, there could be multiple of those conditions in a selector. And for an implementation that might then at the end look a little bit like this, where we have a string which has the complete selector in there. It's just an example in this case. Then I push this into the parser, and the parser returns essentially a list of triples. And the triples are tuples of just those fields we check for, the operator, and the values we want to check for. Yeah, that's essentially step one out of the way. For step two, we have a struct which essentially just will contain the list which we get from our parser when we new up the struct. And in the error case, we just return an error. I also added a quick sigil in there, so we can use that quite easily in the code later. And we eventually need the queryable implementation, and we'll look at the toQuery function next. And for that, we need to take a look at how do we turn this list of triples into an actual SQL query and using Ecto. And for that, we need to look a little bit into the composition of conditions on a query. You might be aware of the simple example where we just check if field needs to equal something to be returned. There's the possibility to add multiple conditions like this, where you can just use and or to add more conditions to a query. And there's also the option to use the keyword list format, where you add many where and or where conditions to a query. But the issue with those are they don't really work for well for my use case, because where and or where, if you use the keyword format in the last example, Ecto will make sure that those conditions are checked in the same order as they are added to the query. So you're rather limited in how you can compose those. And the example of the second line, that needs to be hard-coded if you're doing that like this. So again, that doesn't work if you have some dynamic data which you build the query off of. So in this case, it's not flexible enough, and in this case we need something else, and Ecto has another macro which is really, really useful. That's Ecto Query Dynamic, and one of the things Ecto Query Dynamic allows is the separating the definition of a condition from actually assigning it to a query. So in this case we build up the condition field needs to equal something and assign it to a variable, and then later assign it to a query. And what that allows us is that we can also compose those conditions now. We can essentially build two conditions, field needs to equal something or it needs to equal something else. And then we can compose those for either condition A or condition B need to apply for a result to be returned. And if you're in the space of building any query builder, you certainly want to look at the documentation for dynamic, because it works in a lot of other places in queries where it's really, really useful if you need to build up a query dynamically. So applying that to this example of which we're working on, we take essentially the list of selectors which we get from the parser. We map all the triples to their conditions, looking at the implementation later, and then reduce over all the conditions we get from there and combine them using AND, because all the comma-separated conditions on a selector, all of them need to apply for a page to be returned. And in the end, we essentially assign the condition to the query. For the triple condition, essentially what I do here is I take all the combinations of fields and values, given there might be multiples, and for each of those combinations I build up the SQL to fetch the value, and then I have this big case statement, because what dynamic actually doesn't allow you to do is pass in the operator, so you need to hard code it like that. And in the end we again reduce over all the field value pairs, just this time using OR, because they're alternatives to each other. And there's one thing to note here specifically. I talked in the beginning that one of those things you want to look out for is that you're not creating atoms. The field API on Ecto Query actually at the moment requires the passing an atom for the column name. That's a limitation which is in Ecto. It's possible to remove, but when I asked for it, the answer was like, it would be a big array factor in Ecto. So if someone needs that, they would need to take this up with Jose or someone on the Ecto team. Luckily, for our use case, we can actually work around that a little bit, and that's for the reason that there are field types in ProcessWire. That's another feature I haven't mentioned in the beginning. So essentially, for each of those fields in ProcessWire, there's essentially a field implementation. Imagine like a text field implementation, an image field implementation, a number field implementation. And those implementations actually know what on those which columns are on those tables, so they can actually provide the code which know which column name we have, so we are not dynamically creating any atoms. The interesting part about that abstraction is also essentially the benefit of having a table per field is that you can also have options per field which change how the table looks like. Let's, for example, there might be multi-language in there, so you can see in the example on the bottom, essentially you can have a different language also on the same table, which is kind of interesting. But now we're talking about tables, and when we're talking about tables and not just conditions, we also need to care for Ecto bindings. Essentially, each table used in a query, the abstraction Ecto query uses for those is a binding, and there's multiple ways to refer to a binding after you created a query. And usually, you'd try to use named bindings. It's the newer version of a new way of referring to a binding, but it's really useful if you actually know how a table is named, because you can just refer to it by name, and it's rather simple. I just go through the example. So in the first line, we query for pages, assign it a name page, and in the next line, we can easily pull out just with the keyword list format the binding P for page, and just join another table and assign it also a fixed name, field title, and pull it out in the last line again. But as you can imagine, it's again creating an atom because there's field title in there. I don't even know if there's a title field in my system, so that also doesn't work. So the other version of how you can refer to a binding in Ecto is using positions. So each binding in Ecto is just put into a list in the query eventually, and you can either pull it out, like you can see in the like line 4 of the column. You can either pull it out with a pattern match, where you match based on the position in a list. But the issue is, like, you don't also want to build out a pattern each time you want to refer to a binding on a query dynamically. So there's also in the last line you see a tuple format where you can essentially provide a variable which the binding will be bound to, and an index on that list of bindings of the query. So in this case, essentially we pull out f at the index 1 of all the bindings, and then can later use f to assign a condition again. And for the selector example, this essentially looks a little bit like this. We're again in this toQuery function. It's not highlighted, but in this case, the base is defined actually in the beginning. So we have an existing query, and then we iterate through these selectors, fetch out all the unique fields, so we know which tables to join. We also map those fields with their related field types. That's coming from a global store. That's just basically how ProcessWire works, so I didn't try to find some other way for the mapping there. And then we reduce over all of those sets with an index and build up essentially a lookup table of, like, okay, these are the tables which we joined, and that related to them, like what their indexes are on the query. I also already, what I did here is I used this type.joinTable, because really in the end the field type implementation actually knows best how to join the table it manages. And for the triple condition, that actually becomes a lot simpler as well, because we essentially just pull out the binding index for which table are we interested in, and then let the field type implementation again handle giving us back a dynamic struct with the condition for a certain value. And in the end, this looks a little bit like this. Essentially, we import the selectors module to be able to use the sigil. Then we can use the sigil to just write out a selector, and we can pass that directly into repo.sql right at the bottom. There's a little simplify for making sure that the formatting is okay. But as you can see, all the tables are joined. Like, we have 4 tables because we interact with 4 different fields. And in the big where condition, you can see all the values we have conditions for the product, task goal, 10 and 0 for the number. Yeah, that's essentially the implementing the selectors part. But what about writing data? Like, I talked a lot about querying data and fetching data, but like, that's not everything you need to do with a database. There's schema-based APIs which you'd usually go for. There's insert, update, delete, the usual ones, but As you can see, all of them either need a schema struct or they need a change set built on a schema, so that's not really useful. But there are some query-based APIs, which you probably already know just from a different use case. There's insert all, which, I mean, there's schema or source, but schema really is just a fancy way for Ecto to know the table name. So you can just pass it the table name as well, which just works with any map, any list of maps, essentially, or again, you can use a query to insert data dynamically from other data in the database. And there's also update all and delete all, which, as you can see, the first argument is a queryable. So you can essentially build up a query of what do I want to delete, what do I need to update. Yeah. Usually you'd probably see those for batch operations, because that's really the big use case, which is rather common, because all of those APIs map to a single database query. But those APIs are also really useful if you're working with dynamic data where you don't know the format in the beginning. Yeah, so quick summary of that. We talked about the Ecto queryable protocol, which is really, really useful if you're trying to implement some additional data abstraction on top of SQL. We talked about Ecto Query Dynamic, which is really, really useful for doing query builders of any kind and any complexity. And you can use Ecto without schemas. Thank you.
Thank you, Benjamin. We have some time for questions. We have one there.
Hey, thanks for the talk. Really interesting. So first question I have, I'm assuming this is a product, like a ready thing that you build, the project, and it's working. Before I ask my second question,
I didn't build a product. Like for me, the goal of this was really I used ProcessWire in the past. I really liked the approach, but I didn't get to actually building out that in Phoenix. I might eventually, but I have not yet.
Okay, because it looked very complete. Well, the second question I had is, have you thought about DDL? Because from what I understood, for the fields, you had a separate table for every field, right?
Yes.
So how would you approach creating those dynamically? Is there any API in like Ecto without migrations, right? How would that work?
It's essentially Ecto without migration, yes. So essentially, I looked a little bit into that when I was working on that stuff. It's like you can just issue complete queries against the database, but you don't get all the benefits of the usual migrations you have in Ecto because you're not having a table which manages like what's applied or what isn't applied. So there's certainly a possibility of building something in there which can do something like Ecto migrations do at runtime. The biggest part of why we can't really use Ecto migrations as is mostly due to the fact that it's DSL, essentially. So how do you build up an Ecto migration dynamically at runtime so you can apply it? In the end, my approach would probably be just start with writing out the DDLs for creating the tables and making only parts dynamic which I need, and then use repo.query to apply them.
Thank you. Yeah. I'm here on the other side.
Thank you. Yeah, thank you so much. That was a great talk and like really deep dive into Ecto. Like I was wondering if I would write that, like I'm sure for me there would be these points where I would just have given up and say, just repo query and build the string. You know, like what led you not to do that? And like where do you think is that trade-off or that balance point where you say, now I do repo query as you just said for DDLs, but like this was so deep already, I felt like.
The big part really is that I don't think Ecto query is really built to support queries for creating tables. So the Ecto query abstraction is really for selecting, updating, inserting queries, but it isn't built for queries which are create table XYZ. So that's for me the distinction. the reason why I actually didn't do any string concatenation and just building up the SQL for the use case I showed is mostly because it comes with all the trickiness of string concatenations for SQL queries. And if you can just use Ecto and not run into all of those issues, I still, with Dynamic, you still have all the security benefits of using an Ecto query, where everything is still passed as a parameter, where everything is essentially handled for you. You're not running into issues, whereas SQL injection vectors or something like that.
Thank you. Yeah, this was great.
One more on the front.
Great talk, thank you. Thanks. One question, it might be a dumb question for the database guys in here. Is there like a performance penalty for joining a bunch of tables together every time? Well, I mean, you could have a bunch of fields, like 10, 15 fields or whatever, and to join like 10
There
databases.
certainly is. Like I have worked with ProcessWire, and one of the reasons why I left ProcessWire was at a certain point it didn't scale anymore. But for me, ProcessWire is really appealing for like your general website and like anything like where you're in the like in the lower thousands maximum of things. So it's really great in that space, and it's really flexible. So really, the idea isn't for that specific system to scale to infinity. So there's a trade-off for sure.
Sure, okay.
Any more questions? No, so yeah, a big round of applause to Benjamin.
Thanks.